Hey everyone, here's our math problem for today. Let's say we are given this semicircle O with a diameter of 10 units and this blue rectangle ABCD that is twice as long as it is tall. There are 3 points of intersection between the semicircle and the rectangle as shown in the figure. They are points A, E, and C, where points A and C are also the corners of our blue rectangle. Furthermore, it is given that the length of side AD is equal to the length of segment AE, which is also equal to the length of segment EB. We would like to find the area of this blue rectangle. You can pause the video and try if you can solve this beautiful geometry problem. Now let's solve this problem together. Let's begin by assigning variable to the length of side AD and let that length be equal to x. And since opposite sides of a rectangle are equal, then the length of side BC is also x units. This means that the length of segment AE is x units and the length of segment EB is also x units. Now, since you would like to find the area of the blue rectangle with a length of 2x and a width of x, then area is equal to 2x times x or 2x squared. If we know the value of x squared, then this problem is already solved. We just have to multiply that value by 2 and we know the area of the blue rectangle. Now the problem is we do not know the value of x squared, and that is what we are going to find out in this problem. So what are we going to do? Our main goal here is to be able to find the length of the diagonal AC, and if we can find the length of that, we'll be able to find the value of x. But for that, the first thing that we are going to do is we are going to connect points E and C, and we will concentrate on this yellow triangle. What do we know about that triangle? Notice that we have here a 90-degree angle, and therefore this yellow triangle is a right triangle. Also, the length of side EB and the length of side CB are equal. They are both equal to x. So this yellow triangle is an isosceles right triangle. So this is 90 degrees here. This angle and this angle are the base angles of this isosceles triangle, and they are equal, and both of them are equal to 45 degrees. Now, we have here a linear pair, which means that the measure of this angle is 180 minus 45 or 135 degrees. Now, let's complete the circle so we can apply some properties of a circle. Now, remember that angle AEC is 135 degrees. Now let's connect the center O to points A and C. OA and OC are both radii of the same circle, and they are equal. If the diameter is 10 units, then the radius is 5 units. Then this red arc subtend the inscribed angle AEC with a measure of 135 degrees. And applying now the inscribed angle theorem, the inscribed angle is always 1/2 the measure of either the central angle or the intercepted arc AFC in our case here. So that if this subtended angle is 135 degrees, then the arc it intercepted, major arc AFC, is twice 135 degrees or 270 degrees, which means that the measure of minor arc AEC must be 360 degrees minus this 270, which is equal to 90 degrees. So 270 plus 90 gives us 360 degrees, which is the measure around the circle. Since the measure of arc AEC is equal to the measure of the central angle AOC, that means that angle AOC is equal to 90 degrees from the central angle theorem. This now brings us closer to finding the length of side AC. So let's construct this yellow triangle again. What kind of triangle is this? We know that this is a right angle, and sides OA and OC are both radii of the same circle, and they are both equal to 5 units. So using the Pythagorean formula, the length of side AC is equal to the square root of the sum of the squares of the two legs with a length of 5 units each. And so, computing now for side AC, that is equal to 5 times square root of 2. That is now the length of this side AC. Now, in order to find now the value of x, we can now concentrate on this other right triangle ABC, where angle ABC is a right angle. We know that the hypotenuse is 5 square root of 2. This leg BC is equal to x, and this other leg AB is equal to 2x. So using now the Pythagorean formula the second time, the square of this leg, x squared, plus the square of the other leg, which is this part, is equal to the square of the hypotenuse, 5 square root of 2. So simplifying, 2 squared is 4. The square of the square root of 2 is 2. So 25 times 2 is 50. So combining like terms, 1x squared plus 4x squared is 5x squared. Copy the right side. And solving now for x squared, that is equal to 50 divided by 5, or 10 units. There is no need for us to find the value of x because what we want is x squared. If we know the value of x squared, then we can now find the area of the blue rectangle. So substituting now the value of x squared to this formula, we now have area is equal to 2 times 10, which is equal to 20 square units. So the area of this blue rectangle is 20 square units, and that is our final answer.